We're now going to look at ethological methods. Daniel Lehrman had proposed that we consider two contrasting orientations in terms of the way that different types of people go about pursuing animal behavior research. And it's not that one's better than the other, but they are somewhat different. So one orientation he referred to as the behaviorist orientation. These are folks that are interested in the control of behavior, people like Skinnerians, operant conditioners, those folks, and predicting behavior, maybe arriving at some general laws of behavior, general laws of learning, that kind of thing. I guess, more like a traditional experimental psychologist type of person. Not necessarily a comparative psychologist, though some would certainly fit into this category, but not all. Well, he contrasts the behaviorist orientation with the natural history orientation. Basically, it's observing animals in their natural environment, certainly deriving problems to investigate, perhaps, in a laboratory from what goes on in the natural environment. So basically, the importance of observation and description of ongoing behaviors. Context is also something that's incredibly important to think about, especially when observing animal behavior. For example, this is a study done by Smotherman and Robinson, where they were looking at prenatal reflexes by rat embryos, because they make a whole bunch of them. And here we're only looking at photos of the stretch reflex, and you can see the rat embryo is stretching, and the wipe reflex, wiping its face with its paws. So they decided to look at these reflexes in three different contexts. One was in utero. Now, this is the most difficult type of procedure because basically you are using various optical devices to look inside the mother's uterus. Sort of a compromise is in amnion. So basically you're going to surgically remove the amniotic sac from the mother, which gives you more access to observing the embryos. So it's somewhat easier. But the easiest is being in what they called in bath, inside a saline solution. And so now you're not even looking through the amnion. It's just the embryo is right there in a saline solution that sort of mimics the amniotic fluid. But what they found was kind of interesting in terms of the relative incidence of occurrences of these reflexes. So here are the data. In utero, yeah, of course they occurred, not a lot, but they occurred. In amnion, they occurred more, but in bath, even more. Point being, if a researcher is just going to take the easiest route and look at them in bath, you are actually observing an abnormally higher level of activity than you would either in amnion or in utero. So if you're interested in more naturalistic kinds of occurrences of these reflexes, you really need to be doing the difficult one and look at them in utero, certainly not in bath. Here's another good example of context. It involves rhesus monkeys in India, a study that was first done by Singh, some observations and descriptions of these, what he called urban rhesus monkeys that moved into cities. Nobody put them there. They moved in from the jungles. And the reason they did that is so that they could steal food. It's readily available. These are not necessarily the nicest primates, meaning that if one approaches you, don't protect the food. Give it up. Here's a guy sort of resting. Could have been asleep. I don't know. Wouldn't have mattered. Again, helping themselves to fruit. They'll steal something right out of people's hands. Though I think that kid is intentionally feeding the monkey. And they can be nasty. Like I said, there's one moving vehicle and it just goes right inside. Well, tries to go right inside. But look at this next one. Not that one, because the guy finally figured out. This one, the guy's driving, goes right in the driver's seat and chases the driver. Again, you don't want to put up too much of a fuss when these guys come after you. Let them have their say and then go away. Well, Singh started to compare the various types of social structures that occurred, social organization, all kinds of social behaviors, won't go into the details, of this urban population with ones that had not moved into the cities, ones that were still in the jungle. And he found very important differences in social organization, a whole variety of social behaviors among the monkeys in the cities as opposed to the monkeys in the jungle. So again, a good example of context. And again, they become a bit of a nuisance. This is from 2009. A troop of about 80 to 100 were terrorizing a campus for several years, biting people, grabbing food, like I already mentioned, stealing Pepsi and Coke, hot coffee, not hot coffee or tea. They like cold things, apparently. So they hired a monkey catcher to try round these guys up. So very different types of behaviors with the urban population. Okay, two individuals here. First, Solly Zuckerman. Solly, S-O-L-L-Y, was his first name. Actually, Sir Solly. He was knighted. Sir Solly Zuckerman. He worked in London. And Coomer. I forgot Coomer's first name. Anyway, so Zuckerman, back in the 1930s, was doing extensive observations of a rhesus monkey colony inside of the London Zoo. And he observed that the females had no regular estrus cycles. They always seemed to be reproductively receptive to males. And he actually wrote a book that kind of dominated the way that primatologists felt in general about primates, based upon the fact that females don't have estrus cycles. But again, the problem was he was only looking at these guys in the zoo. So along comes Coomer many decades later in 1968 and decides to observe them in the field, focusing especially on reproductive behavior. And it was just the opposite. Sure enough, the field populations of rhesus monkeys, and they're native to India, that's where he was observing them, do have irregular estrus cycles, like just about every other primate. So, again, a very strong effect of context. By the way, there is one group of animals, the bonobo, formerly called the pygmy chimpanzees, now really bonobo is the common term, where there is ongoing sexual activity, but it's not necessarily reproductive. It's sort of the way they just are social with one another. And it doesn't matter very much if it's two males, two females, whatever.
Pygmy chimps use an unusual means to reduce tension: sex. As with humans, sex has become far more than a means of reproduction. And for bonobos, sexual liberation has taken on new meaning. Participation in sex is a vital part of their society. They engage in sexual activities when they're nervous, when they're excited, when they get up in the morning. Most female primates mate on only a few days each month, signaled by sexual swellings. Pygmy chimps keep their swellings almost all the time, a constant reminder of their readiness to mate. Only female humans have the same willingness to mate at any stage of the sexual cycle. Sex, in one form or another, is part of every relationship. Individuals of the same sex, friends, close relatives, groups. It's not mating, but more like a form of sex play that bonds members of the group together. Even infants take part. Sex is so important in bonobo society that mothers may even initiate their own offspring. The only taboo is between mothers and sons over 6 years old. Bonobos are unique in their use of sex as the binding force in society. They've separated it from reproduction even more than we do. They use it to greet, to appease, to reconcile, and to reassure. Mainly, sexual activity reduces tension, allowing the bonobos to live together peacefully in groups as large as 100.
So, hey, it works for them. This kind of reminds me of the scene from the motion picture The Graduate, in which Dustin Hoffman's character was originally seduced by a woman much older than him named Mrs. Robinson. And in the meantime, he started dating her daughter. But meanwhile, Mr. Robinson didn't know what was going on. But eventually he found out, and near the end of the movie, confronts Dustin Hoffman's character in this scene.
What happened between Mrs. Robinson and me was nothing. It didn't mean anything. We might just as well have been shaking hands.
Shaking hands? Well, that's not saying much for my wife, is it?
You missed the point.
I guess I do.
The point is, I don't love your wife, I love your daughters, sir.
As far as Elaine is concerned, you're to get her out of your filthy mind right now. Is that perfectly clear to you? And that's all, Ben. You'll pardon me if I don't shake hands with you.
So I think bonobos sort of equate sex with, guess what? Shaking hands. Yeah, check this out. So these guys over here are having sex, whether it's for just social or reproductive purposes, who knows. There's a young bonobo that's down there. He just hopped down there. It's not the one, and there he goes. Watch what he does. Kids. Okay, let's with that as an introduction to naturalistic observation, pretty much the effect of context and so on and so forth. Let's look at 5 roles of naturalistic observation in the study of animal behavior. The first is to study nature for its own sake. You want to find out what secrets live in the deep, dark woods? Go out into the deep, dark woods and find out for yourself. By the way, this clip, very short clip from the X-Files, I think is a fantastic quote. Check this out.
Nothing happens in contradiction to nature, only in contradiction to what we know of it.
Makes a lot of sense. Nothing happens in contradiction to nature, only in contradiction to what we know of it. In fact, I like that quote so much, I broke tradition. I never bring popular culture into my scientific writings, but I published a paper in the European Journal of Developmental Science, almost forgot which journal this was, called Nature's Call and Experiential Nonlinearities. No, don't worry about it, what it was all about. But anyway, I opened it up underneath the abstract with that quote, nothing happens in contradiction to nature, only in contradiction to what we know of it. And I'm glad the editor didn't balk at that. They let it go through. Okay, so here's an example of this first role. A whole bunch of studies done by the Cornell psychologist Paul Sherman on Belding's ground squirrel, which are found in the western part of the United States. So this was all field work that he was doing. And notice what these females are doing. They are uttering an alarm call because they've spotted predators, potential danger. And so they are alerting other Belding's ground squirrels to the danger. So having been alerted, they run to cover. So it works, and you'd be correct in thinking that, whoa, wait a minute, that female is putting herself in a lot of danger by uttering the alarm call when she should just go off and hide. And it is the females who do this typically. But, there is a context effect here. They'll only utter this alarm call if there are close kin nearby. And then once they're alerted, then she'll go run for herself. She just has to make sure her kin, typically it'll be her offspring, are safe. So basically, it's altruism, and because it's specific to her own kin, it's a subcategory of altruism called nepotism. Okay, the second role is to use the field as a starting point for what will hopefully become subsequent laboratory investigations. In other words, find out what's going on in nature and then bring the problem into the lab so you know you're studying something that's real. So basically, that was a strategy that I followed in my own work on auditory interactions of mallards and their offspring. I did the same with wood ducks, but much more with mallards. So let me just quick rundown of the mallard situation. Some of this you're a little bit familiar with. So started my observations in the field in a field station near Raleigh, North Carolina, about 12 miles away. And so there's a mallard on her nest. And here is the pre-exodus assembly call that she utters while still brooding her young on the nest, or also in the later stages of incubation. It sounds like this. And that, of course, is a sound spectrogram that we're looking at, just to remind you about that, looking at frequency over time. And then she'll use a slightly different version of that call, a more intense version of that call, has more harmonics when she calls them off the nest a day or two after hatching. If she just walks away without uttering the call, they won't follow her. She has to be uttering that call. So that's the call. Actually, I didn't have movie equipment when I did this work, so I don't have any movies to show you. So what I did, I found this movie on the web where they were nesting, obviously, in someone's backyard, and all I did was add the soundtrack. So that's one of the calls I recorded during a real exodus. You can hear the ducklings and the hen. So that came from my own work, but the film did not. I wasn't studying animals in swimming pools. But then we also observed this alarm call. When there was danger near the nest, the hen would raise her head really, really high and utter this alarm call. And so, these calls evoke different responses on the part of the ducklings that are hearing them. So the assembly call elicits excitation. That is, they'll get all excited, they'll move around, they'll vocalize back, whereas the alarm call has just the opposite effect. So again, these are things that we first observed in the field and then brought into the laboratory to look at some of the underlying developmental mechanisms as to how these behaviors come about, the reactions to the assembly call and the reactions to the alarm call. So I use this here as an illustration of the second role. Now, the third role of naturalistic observations is to validate or add substance to previously obtained laboratory data. So maybe you didn't do the observations and descriptions like you probably should have out in the field. Now you've collected all these data, you're worried maybe they don't mean anything in the real world. Maybe they're just artifacts of laboratory conditions. And I gave an example of that already with tonic immobility. I'm not going to go through all that again. But just to remind you that at least in this case, although we had a lot of laboratory data, at least it was validated by some field observations involving red foxes caching black ducks. The fourth role is to provide information on species variables for efficient laboratory studies. It's important to know the kinds of stimuli that animals typically would react to in the real world. You want to do some kind of color discrimination experiment. You got to make sure you're not dealing with colorblind animals, or if you are, which colors are they able to see, if any, which is an issue. Finding out information about the animals, and by observing what they do in the real world, it's easy to get a handle on that kind of stuff. Or, other behaviors like differences in predation, the way different species go about capturing prey. For example, canids, wolves and the like, rely heavily on one another in capturing prey. There's a lot of social cues going on among them while they're hunting prey. Unlike cats that are more solitary hunters than are wolves, for example. So, knowing this, and you're interested in studying something related to feeding behavior, predation, or whatever under confined conditions, it's good to know what the natural situation is. So this fourth role is done with that in mind. Finally, using the field as a natural laboratory to test a hypothesis. Not all animals take to captivity, but it's really interesting to do some experiments on them, meaning that you now have to go out into the field to do your experimental manipulation. So you're actually manipulating things here. It's beyond observation and description, but of course you would hopefully have done that first anyway. So, for example, a real study on territoriality in red-winged blackbirds.
Males begin these flamboyant displays weeks before female redwings return from southern wintering grounds. This display by the male in the foreground is directed at the male in the background, a strong signal of territorial ownership. But throughout the breeding season, red-winged blackbirds display in full glory. A loud, colorful announcement to keep off their turf.
So notice there's actually two main components to this territorial display. The vocalization, obviously, but also the raising of these red epaulets. So a researcher was interested in finding out whether those red epaulets really played any kind of role in helping a red-winged blackbird maintain its territory against intruders once it set up its territory. So he did the obvious thing. His experimental group, he captured them on their territories and painted the red epaulets black. And then, of course, he had a control group. He also captured these birds just to control for the fact that there was capturing going on. But he painted them with a clear dye so the red shone through perfectly. And then he releases them back onto their respective territories, and he looks to see if there was a difference in terms of whether they were able to keep their territories. Well, sure enough, the experimental animals lost their territories. It's not that they didn't try to keep them. They were vocalizing, and they were raising their now black epaulets, and the intruders just totally ignored them and took over their territories, whereas the control animals were able to maintain their territories once they had established them. So for a red-winged blackbird, red is important in terms of territoriality. So this is a great example, I think, of a field experiment. You didn't have to do it in a lab. In fact, you couldn't. They would not set up territories in a lab, for God's sakes. So, this is an example of that fifth role of naturalistic observation. So 5 roles of naturalistic observation, the importance of context, and Daniel Lehrman's contrasting orientations.